Good morning, dear students. Today we are going to discuss about the super node concept. In the previous class, we have seen what is super mesh and how we can apply the Kirchhoff's voltage law in the super mesh. So, right. So, super mesh means what? That the current source if present as a common source between two loop. Similarly, when you come for the super node concept here, if a voltage source present as a common source between two node, then that super node concept is need to be applied. That means the super node is formed if a voltage source is present between two node. Let us to come for the our numerical. With this numerical we could easily understand what is super node. See, let us take this numerical where I have a node here 1, node here 2 and another one node reference node, right? So node 1 with V1 voltage, node 2 with V2 voltage. Here I have a 2 volt voltage source as a common branch between V1 and V2. I do not have anything else without this 2 volt in this node between 1 and 2. So here you will make a super node by taking this two single node, two individual node as a single node, right? Actually this is one node. We will have KCL here, we can have KCL here, right? But we could not find out current this branch because we have only a voltage. So that's why by making this two node as a single node, you will make a super node. So super node is applied if a source voltage is present as a common branch between two node, right? So here we have one node here, one node here and one node. This is reference node. So V1 and V2, right? We have 1 ampere current source here. There is one current source here and one current will flow this branch, one current will flow this branch. Similarly here one current will this branch and one current will flow this branch, one current will flow this branch. Let us to see the diagram. Let us to see the diagram. So 1 minute. Yes, the same diagram, but I have redrawn them, right? Your V1 node, V2 node, and I have marked this already 2 ampere current. I have marked a current I1 is flow out of this branch and I3 current flow out of this branch, and this I2 current is flow out from this node 2, right? So when you will going to write a node equation for the super node, you will consider this two node as a single node. That's mean you will consider this branch, this branch, this branch, then this branch, this branch, this branch. But when you write equation, you will write with respect to this branch, right? For this node. So you will have one current 2 ampere is coming in to the node 1 and I1 current going out and I3 current going out with this node, right? And in this node the I2 current going out and a current of I3 is coming in and a current of 7 ampere is going out, right? So 2 ampere coming in, I1 I3 going out, and here I3 coming in and I2 and 7 ampere going out. So accordingly you will have your equation Kirchhoff's current law in super node, 2 ampere current coming in and I1 going out and I3 going out there in the first node, and second node I2 going out and I3 coming in and 7 ampere going out. So that is minus, right? So 2 minus I1 minus I3 with respect to your first node and with respect to your second node, minus I2 plus I3 and minus 7. So here you see that with respect to node 1 this is minus I3, with respect to node 2 is plus I3 because the I3 is flowing out from the node 1 and coming to the node 2, and this node 1 and 2 was taken as a which node? Super node. That's why here it is minus and here it is plus, so automatically it will get to cancel. So you will have 2 equal to this I1 come this side, this I2 come this side, 7 is come this side. So you have 2 equal to I1 plus I2 plus 7. This is the current equation for your Kirchhoff's current law in the super node, right? Super node equation we have written. Now we need to write replacing them, which replacing the I1 I2 in the form of voltage. So where I1 is nothing but what? Current is flowing from node 1 to ground. So V1 by 2, right? And similarly, I2 going out from V2. So V2 by 4. That is what written here. V2 5, the reference that is 0, right? So simplifying this equation, you will get to this equation V2 equal to minus 2V1 minus 20. So one equation, two unknown is there. Now what we have to do further, now we have applied the node equation for this super node. So one more equation we have to write for this branch which is not considered yet. So what you consider for that? So you consider all other branch except this branch. So suppose here we have V1, V2. That means that voltage existence here. So you can make a closed loop here like this. So that current direction I assume like this. So you can say current entering minus, leaving plus, entering minus, leaving plus, entering plus, leaving minus. That means this is plus V1 plus V2 plus 2 volt minus V2. This is what equation is written. V1 plus 2 minus V2 equal to 0, because see here in this loop, actually we have here V1 and here V2. That means what? V1 voltage here, that means automatically also negative is connected to reference. Similarly, V2 positive here and negative connected to reference. That's why here V1, here V2 is written. So it is a closed path for this particular branch, right? So if you make a loop current like this direction, so you can say current is entering minus, leaving plus. So this V1 positive, current entering minus, leaving plus. This 2 voltage is a positive, and the current entering plus, leaving minus. This is negative voltage. That's why written V1 plus V2 minus V2, V1 plus 2 voltage minus V2 equal to 0. This is equation. So you have now two equations, one equation from here, one equation from here. So two equation, two unknown. Simply you know how to solve them, right? You solve and you will get the answer for this question. That means solving the both equation, and you will get V1 V2 and I1 I2 also you can determine. That is also you very well. So in this lecture what we have discussed about the concept of super node. So concept of super node is applied if a voltage source is common to two individual nodes, right? If a voltage source is present as a common branch between the two node, in such a cases that two node will be considered a single node and you will form a super node. Before that you should also have the individual node marking at this current, and it is current equation also, current representation also should be done, right? So two node means, so you will have two equation, one equation for super node and one equation for the current, that voltage source, right? So now you could have understood the clearly about the super mesh and the super node concept. Super mesh means it is applied if a current source present as a common between two loop, and the super node is applied if a voltage source present as a common between two node. Simple concept, right? And equation you will make super node equation 1 and another one equation, right? Similarly in case of loop method, that is super mesh equation and another equation, depending upon the circuit. So I hope that you have clearly understand the super mesh and the super node concepts, because they are the very important things. In many circuits you may have some common current sources in some diagram and common voltage sources in some diagrams. So you have to have thorough knowledge about the super node and super mesh concept. So I hope that you have clearly understood, and we could see in another lectures with another topic. Thank you very much for listening this lecture.